I hope you paused the video and did the problems. I've got those solutions for you here. And I apologize for how yucky this looks. As I get to the right side of my tablet, it doesn't work as well. So I hope that you are able to see that what's under the radical here, that's a 3, and then that's a 2. This says ran out of room, see next page. You can hardly see what that says. So I did want to take a minute, I rewrote this, and let's talk a little bit about the results for sine of negative pi over 2. This is the first time we've seen this result of undefined. So what we are now seeing is, okay, not every angle is an angle that we can take the tangent of. Not every angle is an angle that we can take the secant of. And think about why that would be. If we end up with a 0 in the denominator, that result is going to be undefined. So we think of not defined. The angle negative pi over 2 is not defined for its tangent value. It is not defined for its secant value. And there are certainly lots of other angle values as well as trigonometric functions for which that is true. I will point out though that sine and cosine applies to every angle on the unit circle and beyond. We've seen several in our examples here that we had to do some coterminal work with, but you can find the sine of any angle and the cosine of any angle. All right, moving on to some identities that we have. We have lots of identities in trigonometry, and you're going to need to learn these as we go. So you've got the whole unit circle to learn. That's a lot. And now we're going to start to add to it a series of identities. We've already talked about the definitions of the trigonometric functions, which need to be learned. And now we have the reciprocal and the quotient identities. We're actually going to talk about the quotient identities first. So with the quotient identities, we have, the quotient is division. Notice in our list of functions that we've already seen, we've looked at these before, tangent and cotangent are the quotients of the x and the y values. But the x value is the same as the cosine of the angle, and the y value is the same as the sine of the angle. So we could rewrite the tangent of any angle. Since it is y divided by x, we could replace the y with the sine of t, and we could replace x with the cosine of t. So the tangent of an angle is the same as the sine of the angle divided by the cosine of the angle, the quotient of those two. This hopefully reminds you of some things you've heard in geometry before, but this is called a quotient identity. Similarly, cotangent of an angle is the x value divided by the y value in that ordered pair. So we have the cosine divided by the sine of an angle. Cosine of an angle divided by the sine of an angle. I want to try not to say just the cosine, because that would be like me saying, everybody right now take the square root. And your question is, square root of what? Similarly, you can't just say take the cosine. You'd have to say take the cosine of an angle. So I'll try to be more precise with my language. But these are the quotient identities. Then we have the reciprocal identity. So I want you to think about with reciprocal, that means we flip the numerator and the denominator. Each of these angles, or each of these trigonometric functions, is the reciprocal of another function. I want you to notice, please, sine and cosecant. The cosecant, let's make that not quite so big. The cosecant of t is equal to 1 over y. But y is the same as the sine of t. So the cosecant of an angle is the reciprocal of its sine. Similarly, sine would be the reciprocal of cosecant. They are reciprocals of each other. I would like for you to consider 3/4 and 4/3. 3/4 is the reciprocal of 4/3. 4/3 is the reciprocal of 3/4. They are reciprocals of each other. We oftentimes think of cosecant of an angle is the reciprocal of the sine of the angle, and that's true. but it works both ways. So when you know one, you kind of know two, and you'll see that quite a bit as we go. All right, now let's take a look at another pair of reciprocals. Let's take a look at cosine and secant. Wouldn't it be nice if the cos went together? They do go together in another identity, but not in this identity. So the secant of an angle is 1 over the x value, but we know the x value of the ordered pair is the cosine of that angle. So the secant of an angle is the reciprocal of the cosine of that angle. Similarly, the cosine would be the reciprocal of the secant. They are reciprocals of each other. And last in our list here, we've got the tangent and the cotangent. The cotangent of t is equal to x over y, which we already talked about as cosine over sine, the tangent of t. Similarly, the tangent of t is the reciprocal of the cotangent of t. So we've got some quotient identities and we've got some reciprocal identities. So let's go through an example using these identities. Given that the sine of an angle, now notice we're switching from t, one of our typical letters in our alphabet, to a Greek letter. We use a lot of Greek letters to represent angles in trigonometry, so we're just getting some practice with that. Let's say that we want to use the reciprocal and quotient identities to find the values of the other trigonometric functions of theta. So I know that the sine of theta is negative square root of 15 over 5, and I know the cosine of theta is square root of 10 over 5. I do want to, so let's walk through that. I've tried not to go too far past them, but I may have to just to get my tablet to work well. So I want to use my reciprocal and quotient. I'm going to start with my quotient identities. So I will find the tangent of the angle. Instead of t, we're using theta this time, by taking the sine of the angle, which is negative square root of 15 over 5, divided by the cosine of the angle, which is square root of 10 over 5. We'll simplify this. If you have your TI phenomenal calculator, please feel free to use that and not suffer through what we are doing here. So we have negative square root of 15 over the square root of 10, when those 5s divide out nicely. Okay. And 15 over 10, I can reduce that a little bit. Oh, rationalizing and reducing is so annoying to me. 5 goes into both, so that's 3 over 2. If I multiply by 2 over 2, I have negative square root of 6 over square root of 4, which is 2. So the tangent of theta would be equal to negative square root of 6 over 2. Okay. Now I will do the cotangent of theta. I will use a quotient identity, although I would much rather use a reciprocal identity. So if you can pick, and it says that we can, feel free to use the reciprocal, but I just want to demonstrate the quotient nature of cotangent. So I'm going to scroll up. It's getting hard to write on my tablet like this. So I will do cosine of the angle divided by the sine of the angle, which is square root of 10 over 5 times negative 5 over square root of 15. Dividing by a quantity is the same as multiplying by its reciprocal. We'll divide out my 1's there. And I have negative square root of 10 over square root of 15, which is negative square root of 10/15, which is negative square root of 2 over 3. I'll multiply by, I should have emphasized earlier we can only multiply radicals times each other. So this isn't really me multiplying back here by 2 over 2. I meant for that to be extended under that radical or to be in a separate radical. So for more specific ways to do that, the way to do that, I should have included that. So we have the negative square root of 6 over square root of 9, which is 3. Now here, you may say, Ms. Hall, those don't really look like reciprocals of each other, and they should be, because tangent and cotangent functions are reciprocals of each other. So I've just shown over here, if I had taken the reciprocal of negative square root of 6 over 2, that would be negative 2 over the square root of 6. When I rationalize this, here's the result. 2 goes into 2 once and into 6 3 times. So we do see, and it would be negative, we do see that we get the same thing if we had used the reciprocal identity. Okay? Now let's take a look at, let's say we've done tangent and cotangent of the angle. We still need to do secant and cosecant. So we'll change colors here. I'm not going to be able to leave those up there and have this right well, so just refer to your notes. So we'll start with the cosecant. The cosecant of our angle is the reciprocal of the sine. So here's my sine value. I will take the reciprocal of that. I will multiply by the square root of 15 over the square root of 15, rationalizing that denominator. Negative 5 square root of 15 over 15, which reduces to negative square root of 15 over 3. And then for the secant of the angle, using my reciprocal identity, I recall that secant is the reciprocal of cosine, so I'll take the reciprocal of the cosine of the angle, which is 5 over the square root of 10. I will multiply by the square root of 10 over the square root of 10 and get 5 times the square root of 10 over 10, and then 5/10 reduces to 1/2 square root of 10 over 2. So now you see how you can, if all you know is the sine and the cosine, you're able to find every single other function using the quotient identity and the reciprocal identity.